Hello everyone, I'm Paul and today we're solving problem 2962, count subarrays where max element appears at least k times. So this is a medium subarray problem and we know that num's length will be smaller or equal to 10 to the power 5. This means we need to come up with a solution that runs in something better than big O of n squared. So let's see what this solution is. So we're given an integer array nums and a positive integer k, and we need to return the number of subarrays where the maximum element of nums appears at least k times in each subarray. For example, let's say we have this array and k equals 2. Now the max element for this array is 3, and we need to count the number of subarrays in this array where 3 appears at least k times, in this case 2 times. So for example, this subarray is valid because it has 2 3's. This subarray is also valid. This one is valid. This one is valid. This is valid. And this is valid. So the result for this is 1, 2, 3, 4, 5, 6 subarrays. So we return a 6. So just to be clear, remember that a subarray is a contiguous sequence of elements within an array. So this is a subarray, this is a subarray, this is a subarray, or the entire array is also a subarray. Okay? Now the question is, how can we solve this in big O of n, or at least something that's better than big O of n squared, because remember that nums.length is smaller or equal to 10 to the power 5. So the answer is with sliding window. Next we'll see how can we apply this approach. Now let's use the same example. This is the array and this is k, and we know that for this one the max element is a 3. So we will create two variables, one count and one for the result. And now we will iterate this from left to right with 2 pointers, left and right, initially at index 0. And we will start moving the right pointer. And each time we find a maximum value, in this case a 3, we will add 1 to the count. So 1 is not the maximum value, so we update the right pointer. Now right is here and 3 is our maximum value, so the count is now 1, and we update right pointer again. Now right is here and 2 is not our maximum value, so we update right again. Now right is here and 3 is our maximum value, so now the count is 2. And now our count equals k. So let's see what this means. We know that this array is valid because it has 2 maximum values. But we also know that this array is valid because it also has 2 maximum values. So our approach here is to update the left pointer until our count is smaller than k. And from that point we want to add the left pointer arrays to our result. So in this case, nums at left pointer is 1. 1 is not our maximum value, so we update left. Now left is here and 3 is our maximum value, so we subtract 1 from count, which is now 1, and we update left again. Now left is here and our count is smaller than k. So at this point we can add left arrays to our result, and left is at index 2, so our result is now 2. And remember, this means this array is valid and this array is valid. This is basically the entire pattern for this problem, so let's continue. Now we update right. Now right is here and 3 is our maximum value, so we add 1 to our count, which is now 2. And 2 equals k, so we need to update left until count is smaller than k. 2 is not our maximum, so we update left here, and 3 is our maximum value, so we subtract 1 from count and update left again. Now left is here and count is smaller than k, so we add left subarrays to our result, meaning our result is now 6. This means that this subarray is valid, this subarray is also valid, this one is valid, and this is valid also. And finally we update right, we reach the end, and we return the result, which is 6. Now remember, we are using sliding window, and time complexity will be big O of n, and space complexity will be big O of 1. So now let's go with the code, and hopefully you will get the idea. First, let's say n equals length of nums, and our target equals the maximum value within nums. Count equals 0 and result equals 0. Next, we'll start our left pointer at 0, and we will iterate right pointer in the range from 0 to n. Now first we will update the count of the max element. So if nums at the right pointer equals target, count plus equal 1. Next we will update the left pointer until our count is smaller than k. So while the count equals k, if nums at left is our target, we need to subtract 1 from our count, and next we update the pointer. And last, we need to add all subarrays from 0 to the left pointer. So result plus equal left. Because remember, we are looking for subarrays where the maximum element appears at least k times. So once we find a subarray that's valid, we can add any element to that subarray and it will still be valid. So finally we return the result, and this is the entire code. Now let's submit this and see if it works. As you can see here, this works and it's very efficient. So if you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.